Okay, then in last class we discussed up to the question number 3 of exercise 6.2 triangles. Today we will go ahead from question number 4th. Okay. So now we have in question number 4th, it is given that in figure 6.19, DE is parallel AC. It is given that DE is parallel AC. DE is parallel AC and DF is parallel AE, means this line is parallel to this line. Okay. And we have to prove कि BF upon FE is equals to BE upon EC. So beta, when you suddenly think how to prove this, you may not go to that way कि how we can prove it. So there is a way of thinking here, okay, कि how we can prove it. For that, first of all, you have to think what is given here, and you will go through the given things. You may get these things, okay. This is the way of thinking when you have a question. When a question comes and someone puts a question in front of you, how will you think? This is the important point. If you know how to approach that question, you may find the solution. Even if you have not solved it before, you can get the solution. What is the right approach? I mean to say कि go through the given things. If you see कि this BF is upon FE is equals to BE upon EC, you may get confused कि how these things will come here. Okay? For that, when you go through the given things, you may get these things. So let's see what is given. DE is parallel AC. DE is parallel AC. So now we have learned a BPT theorem, na, कि if the line is parallel to one side of a triangle, so here ABC is a triangle, right? In triangle ABC, it is given that DE is parallel AC. DE parallel AC. So what we can deduce from DE parallel AC? We can deduce कि BE upon EC is equals to very good BD upon AD or DA, right? By BPT. You may think कि what is the relation of these things from with this thing? We have to prove this thing, na? So you may think it right now. You may think what is the relation, but don't think in that way. What I said कि if D is parallel AC, these things can be happen. Now write it here. Again, DF is parallel AE. DF is parallel AE. So here we have to select this triangle ABE. Yes. This time we will select this triangle, na? ABE, because DF is parallel AE, right? A is not the part of triangle ABC, so we cannot take triangle ABC. AE is the part of triangle ABE and DF is parallel of A. So we will write in triangle AEB, it is given that AE is parallel DF. So we can write BF upon FE, right? BF upon FE is equals to BD upon AD, right? By BPT, make this equation 2. By observing equation first and second, you can see कि BD upon AD, BD upon AD is equals to BE upon EC, and BD upon AD is equals to BF upon FE, right? So things which are equal from same things are equal to each other, na? So we can say कि BF upon FE is equals to BE upon EC. Okay, from first and second. Okay. Any doubt? Now the fourth one is over. Let's move to the question number 5th. In question number 5th, it is given that in figure 6.20, DE is parallel OQ. DE means this line. DE is parallel OQ, this line, and DF is parallel OR. It is given. Okay, and we have to show we have to show कि EF, what it is, EF, we have to show कि EF is parallel QR. Okay, we have to show EF is parallel QR. Suppose you have a triangle like this, okay, and this is the EF and this is QR, and you have to show that this line is parallel to this. Then remember the converse of BPT. What is converse of BPT? Converse of BPT is कि if the ratio of these two, this upon this, is equals to this upon this, that means कि this line is parallel to this. So we can have a way by which we can show कि this is the parallel to this. We may have another way also, but as we are studying the triangle and the things related to similarity and BPT theorems, so we will always think like that, na, related to those theorems. Someone may also think, sir, if we will prove this angle equals to this, then these two are the corresponding angles, so the lines are parallel. You may think like that, but in this chapter and here, we always have to think about the theorems and axioms which we have studied in this chapter. So we have studied the converse of BPT that says if this upon this is equals to this upon this, in that case this is parallel this. So think away कि can you see can you show कि PE upon EQ is equals to PF upon FR in this triangle. So for showing that we have to look and go through the given things, right? As I mentioned in last question, कि we will have to go through the given things. If you think directly कि how can we show that, you may get confused. But when you go through the given things, you may reach to the conclusion and you can solve that question. Okay, so let's see. First thing is here कि DE is parallel OQ. DE is parallel OQ. So we can apply BPT in this triangle PQO. So let's write here. In triangle PQO, okay, in triangle PQO, D is parallel OQ, DE parallel OQ. So what we can write? We can write PE upon EQ. PE upon EQ is equals to PD upon OD. PD upon OD by BPT. Right? You may write it like equation 1. Now other given thing is DF is parallel OR. So DF is parallel OR. So we can apply BPT theorem if the two lines are parallel, but that must be in a triangle. So here triangle you can see is POR. POR. In triangle POR. So now write in triangle POR. In triangle POR, DF is parallel OR. So we can write कि PF upon FR is equals to PD upon OD. Again BPT. Make this equation as equation 2. Now by observing equation first and second, you can see PD upon OD. PD upon OD is equals to PE upon EQ and PF upon FR. Right? Yes. So we can write कि PE upon EQ is equals to PF upon FR. Reason from first and second. Okay? Yes. So here PE upon EQ is equals to PF upon FR. This PE upon EQ is equals to PF upon FR. So in triangle PQR we can say ना कि EF is parallel QR, है ना? तो We will write it here. In triangle PQR, in triangle PQR, in triangle PQR, we have PE upon EQ is equals to PF upon FR. This implies that EF is parallel QR. Okay, by converse of BPT. Okay, Aman?
Yes.
So let's move to the next question, that is question 6. Move to the next question. Question 6. The figure of this question is also given here in figure 6.21. This figure 6.21, A, B, C are points on OP, OQ and OR. You can see ki A is on OP, B on OQ and C is on OR in this triangle, and respectively such that it is given that ki AB is parallel PQ and BC is parallel QR and AC is parallel PR. Okay, it is given here. This AB is parallel PQ and BC is parallel QR and AC is parallel PR. It is given. And we have to show that BC is parallel QR. What we have to show that BC is parallel QR. Once again, if you will directly think how I can show that BC is parallel QR, you will get confused. Okay, so go with the given things. Okay, so what are given? Given is that AB is parallel QR. So go through it.
AB parallel to PQ.
Yes, AB is parallel PQ. Okay, so you can see that AB is parallel PQ is relevant in the triangle OPQ, right? So we will write in triangle OPQ, in triangle OPQ, AB is parallel PQ. Okay, AB is parallel PQ. So what we can write? OA upon AP is equals to OB upon BQ.
Yes.
By BPT, because the lines are parallel. So we will write ki OA upon AP will be equals to OB upon BQ by BPT.
Sir,
Yes.
AB upon AU.
OA upon AP
AB upon
OB upon BQ.
reciprocal.
बेटा The sequence or order must be same, na? Here we have taken OA upon AP. Here we have also taken OB, right? Upon BQ, no problem. You can also take AP upon AO, then you will take QB upon BQ. Okay? If you will take AP upon AO, then you will take BQ equals to BQ upon BQ, and when you are taking OA upon AP, you will take O equals to OB upon BQ. You can take both of them. It depends on you. So no problem by taking this. Okay. Now again, what is given? AC is parallel PR. AC is parallel PR. So in triangle OPR, because AC parallel PR is relevant in triangle OPR. So in triangle OPR, है ना? AC parallel PR, this implies that you can write OA upon AP, OA upon AP is equals to OC upon CR. Okay?
Yes.
By BPT. As in this triangle we have taken OA upon AP, so whenever this side comes, take OA upon AP, not one time AP upon OA or one time OA upon AP, because that will confuse you. So OA upon AP is equals to OC upon CR. Okay. make it equation 2. Now once again only these two things are given. So what we conclude here by observing these two equations, OA upon AP is equals to, so we can see कि OA upon AP is equals to OB upon BQ and OC upon CR. So from first and second you can write OB upon BQ is equals to OC upon CR, right? CR. Now OB upon BQ, let's see in triangle OQR, OB upon BQ is equals to OC upon CR, that means BC parallel QR by converse of BPT. So now let's write कि in triangle OQR OB upon BQ is equals to OC upon CR. Proved, right? This implies that BC is parallel QR by converse of BPT. Okay? Okay. If you want to note it down, you can. Okay. Done. So let's move to the next question. Beta, let's move to the question number 7. What it is? Question number 7. Using theorem 6.1. Using theorem 6.1. What is theorem 6.1? Basic proportionality theorem. That is, what is basic proportionality theorem? Sorry. What is basic proportionality theorem?
If one side is connected to the other side, it is become in the ratio, the same ratio.
Using theorem 6.1, here it has written कि using theorem 6.1, so first we have to remember what is theorem 6.1. Theorem 6.1 is the Thales theorem or BPT. That is कि if a line is drawn parallel to one side of a triangle, if a line is drawn parallel to one side of a triangle intersecting other two sides, it divides other two sides in the same ratio. Means, suppose here is a triangle ABC and EF. Here EF is parallel BC, then AE upon BE is equals to AF upon CF, right? This is all about theorem 6.1. So using this theorem we have to prove, what we have to prove? Prove that the line drawn through the midpoint of one side of triangle parallel to another side bisect the third side. Okay. It has also written here, recall that you have proved it in class 9th. Okay, this was the midpoint theorem actually in class 9th. Okay, if you draw a line, it is a midpoint theorem in class 9th. What is midpoint theorem? Ki you draw, when you draw, or you can say it is the converse of midpoint theorem, and theorem says ki, suppose we have a midpoint of one side of a triangle, triangle's name is PQR, and A is the midpoint of PQ. A is midpoint of PQ. Okay. A is midpoint of PQ, and you draw a line from A, and that must parallel to QR also. This line is parallel to QR, means this is parallel to this, and it intersects the PR at point B. Okay. Then B is also the midpoint of PR. B is also the midpoint of PR. This was the theorem in class 9th. And here we have to prove it. If you draw a line that is parallel to one side of a triangle, and it has drawn from the midpoint of one side, means it has drawn from midpoint of one side and parallel to another side, it intersects the third side at its midpoint. Okay, so here A is the midpoint of PQ. It is given. Given, what are given things? Given A is midpoint of PQ, and what else is given? A is midpoint of PQ, and what else? Anything else is given? No, one another thing is given, beta, ki AB is parallel PQ. Yes. So here A is midpoint of PQ and AB is parallel QR. These two things are given. Okay. These two things are given. Okay. First of all, you will draw a triangle. So you can write here we have here we have triangle PQR, है ना? We have triangle PQR in which A is midpoint of PQ. Okay. A is midpoint of PQ. These things are given. Okay. Now the given things I have written here. What are the given things? And what we have to prove? We have to show or prove. We have to show that B is midpoint of PR. Okay. What we have to show? That B is midpoint of PR, sorry. Okay. So let's see how we can show it. Once again, we will remember the theorems what we have studied. Okay. And we will go through them. What is given here? Here given ki A is midpoint of PQ and AB is parallel QR. So A is midpoint of PQ is not very relevant with the theorems what we have studied in this chapter, but AB is parallel QR is very relevant because BPT theorem is all about the parallel line. Na? So AB is parallel QR is very relevant. So we will go through this. Here AB is parallel QR. That means AP upon AQ is equals to BP upon BR, right? So we will do that. Let's see what happens. In triangle PQR, AB parallel QR. So we can write AP upon AQ is equals to BP upon BR, right? By BPT. Okay? Now, here in this question, two things are given. One, AB is parallel QR, and we have utilized this. We have utilized this by writing write these things here. Okay, but we haven't utilized this thing, right? A is the midpoint of PQ, and so we have to utilize it also because we have to prove that B is the midpoint. Until we have not proved it, so try to utilize how can you utilize the A is the midpoint and what you deduce from it ki A is the midpoint. If A is the midpoint, that means ki AP will be equals to AQ.
Yes, sir. PA is equals to AQ, na?
Right, both are the same thing. Yaar. AP is equals to AQ or PA is equals to AQ. What are the difference? AP is equals to AQ. Why? Because A is the midpoint. So here AP is equals to AQ means if the both things are equal and the equal divided by equal makes 1. Right?
Yes.
So you can write AP upon AQ is equals to 1 and now write it BP upon BR. Why we have written AP upon 1 instead of AP upon AQ?
But B is also midpoint of PR.
No, B is not the midpoint of
PR.
PR. We have to show that B is the midpoint of, focus here, we have to show B is the midpoint of PR. The given thing is only two things, A is the midpoint of PQ and AB is parallel QR. Okay. So we can write AP upon AQ as 1 because the reason is AP is equals to AQ, okay, as A is midpoint of PQ. Okay. So now by transposing this you can write कि BR is equals to BP. Okay.
Yes.
By transposing this to this side you can write कि BR is equals to BP. This implies that B is this implies that B is midpoint of PR. Hence